Hello there. In our last video, we talked about differentiation, how to find derivative of functions, and we restricted ourselves to finding derivative of polynomials. But we are going to go a step ahead of that right now. We are going to be calculating or finding the gradient of a curve or of a function. In this case, we are still talking about polynomials. Now, we probably have been used to drawing parabolas and then drawing tangents to the curve and then using the formula change in y with respect to change in x, that is y2 minus y1 divided by x2 minus x1 to find the gradient of the curve at a particular point. We are going to do exactly the same thing here, but this time around we are going to be using a faster way, and that is differentiation. But before we proceed to finding gradient of a function, remember the last time we started by looking at very simple differentials of some functions, and then I have made a table here to try and summarize those things that we did last time. So if we have a function y given as x, we can find the derivative of y with respect to x, and that will give us 1. The derivative of y equals x squared, that is the y function equals x squared. Derivative of x squared in that sense will give us 2 times x, that will be 2 times x raised to the power 1, and that of x cubed will be 3x raised to the power 2. x4 will give us 4x cubed, and then 5x to the power of 5 will give us 5x to the power of 4. And then lastly, we have x to the power of 6 is 6x to the power of 5. Remember, we used a formula or a symbol that we refer to as the differential coefficient, that is our g dx. So we said that you can be given a function y, and then the y is given as in terms of x, then you can find derivative of y with respect to x. And we said that you could even be given the function y with respect to defined in terms of other letters, may not be x. So we can find derivative of the function given with respect to the particular letter that is given in the question or in the function. And last time, we ended up by writing this particular formula or particular expression as the derivative function, as the gradient function, please, as the gradient function. So if I have y equal to x to the power of n, the derivative of x to the power of n, that would be y dx, and that will be defined as the n multiplying x from the front, and then we have minus 1 from the power. At least we subtract 1 from the power. So this we have said is a derivative of y with respect to x. And this is a gradient function. And if in the case where we have a constant, such as a in this case now, with the x to the power of n, derivative of that function will be n times the a, then we have x raised to the power n minus 1. So we have the same thing. They are the same. They are the same. It's the same form. It's one and the same formula, so they are not different. It's just that when you have functions that have constants attached to the x variables, then you have to use the power to multiply the constant from the front. All right, so suppose we want to find the gradient of the curve y equal to x squared at the point 5, 9. If we are given a curve y equal to x squared and we are to find the gradient at this point, usually we would be drawing the curve. If we're not using differentiation, we'll be drawing the curve and then drawing the tangent to the curve also. And then the tangent will be drawn at the point where x is 5. So even if we are given we are asked to find the gradient of the curve at this particular point, we'll be interested in drawing the tangent to the curve where x is 5. The y will be of no interest to us as long as it is the gradient we are only trying to look for. So let's see what this looks like. In the beginning, we already said that if we were not using differentiation, we would have actually have to use this formula. And using this formula means that we are given 2 points which the particular function passes through, or particular line passes through for gradient of a line. We're given 2 points where the line passes through. Then we use the formula and we evaluate and find our gradient. But remember, I just mentioned gradient of a line. So in this case, we are going to be finding gradient of a curve. And therefore, we cannot actually find the gradient of the entire curve, but we can find the gradient of a curve at a particular point. We can find the gradient of a curve at a particular point. So the point given to us to find the gradient is what we hold on to. And what do we hold on to in that sense? We hold on to the value of x at that particular point. I'm sure this will become clearer when we look at the concrete examples we'll be solving right away. So starting with this, we have to find the gradient of the curve y equal to x squared at the point 5, 9. Now, in doing this, assuming I have to draw the graph of this, now noting the points where x is 5 and y is 9, what I do is I will draw a tangent or a line to that, a line against the curve at that particular point. A line that is drawn against a curve or that is drawn to a curve so that it touches the curve at just a single point. For example, in this sense, the line is drawn to touch the curve at that particular point, just a point. That line is called a tangent. If it is drawn against the curve and it touches the curve more than a point, in that sense, it could be running through the curve. If it runs through the curve, then it would have touched the curve at 2 points. So that will no longer be a tangent. So what we are saying in a sense is that when you are calculating or finding the gradient of a curve which has been drawn, the steps to follow is draw the tangent to the curve at the point which you are asked to find the gradient. So in this case now we have the point 5, 9. And I said earlier that we have no interest in the y value. Our interest is solely on the x value. In this case, x equal to 5. So we draw the gradient, we draw the tangent against the curve at the point where x is 5. And then we complete the triangle. Of course, if you were doing that using a graph, you complete the triangle and then find the change in y value to the change in x value. And using this formula, y2 minus y1 over x2 minus y1, that will give us the gradient if we were to draw the curve. But like I said, this lesson is addressing the calculation of gradient using differentiation. So we have no need of drawing the curve. So how do we go about it? First thing is to find the derivative of the function y equal to x squared. So what is dy dx? When y equal to x squared, dy dx is 2x. The derivative is 2x. Remember, this is the gradient function. This is referred to as the gradient function because it simply helps us to calculate the gradient. It is a function or an expression or an equation that helps us to calculate the gradient. So your dy dx is the gradient function. So our dy dx in this case is 2x, and that is our gradient function. Hence, it is what is required to find or calculate the gradient of this function, y equal to x squared. So the next step is we put in the value of x in our point. The value of x in our point is 5. So substituting the value of x into our gradient function, that is 2x, we have dy dx equal to 2x, and then the gradient will be 2 times our x value, which is 5, and that will give us the gradient as 10. Let's take another example. Find the gradient of the tangent to the curve y equal to 3x squared minus 5x at the point minus 1, comma 7. At the point minus 1, comma 7. So step 1 is to find the gradient function. Our gradient function will be dy dx, that is the derivative of y with respect to x, and that will give us 6x minus 5. 2 times 3, that's 6. Then we have x raised to power 2 minus 1. So you subtract 1 from 2, that will give us x raised to power 1. So we have 6s minus 5. So this is our gradient function. That is what we require to find the gradient. So at the point where x is minus 1 and y is 7, remember we only need the value of x to find our gradient. So when we have x as minus 1, our gradient dy dx will be calculated as 6 times minus 1 minus 5. And the end of that calculation will give us the gradient as minus 11. Another example says find the gradient of the curve y equal to 7 minus 2x plus 3x squared at when x equal to 3. So the same step again. First find the gradient function dy dx. In this case that will be minus 2 plus 6x. Minus 2 plus 6x. And the gradient at the point where x is 3. So you can see in this question, we are not given the coordinate point. We are just given the value of x at the point where we are expected to calculate the gradient. So you could be given the coordinate point and you could be given just the value of x at that particular coordinate point. So we are not interested in the y value since we are only calculating the gradient. So at the point where x is 3, we substitute 3 into our gradient function. That will be minus 2 plus 6 times 3. So the end of that calculation will give us the gradient of the curve as 16. Now we're going to move a step further. Find the point on y equals 4x squared minus x minus 5, where the gradient is 15. Now the point refers to the coordinate point where our tangent is expected to be drawn so that the calculation of the gradient at that point will give us 15. So in this question, what it means is that we are given the gradient of the curve, but we are asked to find the point, the value of x and the corresponding value of y, where the gradient of this curve will turn out to be 15. So let's start with the steps we had described, we had talked about in calculating the gradient in the previous example. So we find the gradient of the curve first by using or finding the gradient function. The y dx in this case is going to be 8x minus 1. But we are told that the y dx or the gradient is 15. So that the y dx is 15, we can write 8x minus 1 equals 15. Solving that equation gives us the value of x as 2. Now remember, we are looking for the point. The point consists of an x value and a corresponding y value. It must be written as a coordinate point when found. So we have already found the value of x. Now we need to find the value of y. What we'll do is that we substitute the value of x as 2 into the original y function. We substitute the value of x as 2 into the original y function. So when we do that, we have y equals 4 times 2 squared minus 2 minus 5. And the end of that calculation will give us y as a 9. So the point where we have the gradient calculated to be 15 is x equals 2 and y equals 9. So that we can say that the gradient of the function is 15 at the point where x is 2 and y is 9. Let's take one more example to round this lesson. Find the point on the curve y equal to 5x squared minus 3x minus 1, where the gradient is 27. Again, we are given the gradient. We need to find the point where this curve's gradient can be calculated as 27. So the step again, find the gradient function, dy dx. So dy dx in this case will give us 10x minus 3. So the calculation of that means that we can equate 10x minus 3 as 27. Because if this is the gradient function, then it is equal to 27. All right, so we have our 10x minus 3 equals 27. Now solving that equation, we're going to arrive at x as 3. So we have got the value of x as 3. Now we need to substitute into the y function to get the value of y, or the corresponding value of y. So in doing that, we're going to have, when x is 3, y equals 5 times 3 raised to the power 2 minus 3 times 3 minus 1. So evaluating this, we're going to arrive at y equals 35. So x equals 3, y equals 35 makes the coordinate point where we have the gradient of this curve calculated as 27. So that we can say that the gradient of y equals 5x squared minus 3x minus 1 is 27 at the point 3, 35. You may want to rewind the video or watch it over again to get clarity on everything that have been explained in the examples that have been solved. In our next video, in our next lesson, we will be looking at integration. We will be looking at definite and indefinite integrals, but we'll take it one at a time, and then we'll round up everything on calculus. But before I go, I just need to let you know that it's possible that you are given a polynomial where the degree is not 2. What I mean by the degree, I mean the power here is not 2. You can have the power as 3. And if you have the power as 3, it means that when you differentiate this function, you're going to be having a quadratic. 10x minus 3 is a linear function. If you differentiate that which has a power of 3, you're going to having something that is a quadratic. In that sense, you're going to be solving for the value of x and then getting 2 possible values of x. What that means is that getting 2 possible values of x will result in getting 2 corresponding values of y. 2 corresponding values of y, 2 corresponding values of y for the values of x means 2 points. That means the gradient of the curve can have the value that is given. For example, if it was 27, can have that value of 27 at those 2 points. So it is possible to have something that is different from this, where we have just a single point. We can have 2 points where the gradient can be calculated and we have the same value. That ends our lesson for today. I hope to see you in our next meeting. Have a wonderful